In the previous video, we calculated thrust forces and overturning moments for submerged square surfaces. Now we're going to repeat those calculations, except this time we have a circular submerged surface. The circle on the right-hand side of the diagram represents the surface when viewed from end on, whereas the rectangle on the left-hand side represents the circular surface when viewed from the side. We have various different things labelled on our diagram. We have a distance h, which is the distance from the free surface of our liquid to the top of our submerged surface. We have a measurement d, which this time we can see is the diameter of the circle. We have y bar labelled, which we said was the distance to the centroid of our submerged surface, or the horizontal centre line. And we have a distance h bar, which is the distance to the centre of pressure. So the first thing that we're going to calculate here is y bar, because it features in a number of our formulae. And we can see here, with reference to h and d, that y bar is just h plus d over 2, or the height plus the radius of the circle. The height is given as 6.5. D is given as 4.5, giving us a y bar value equal to 8.75. And that's the same y bar value that we had when we used the square submerged surface. The next thing we need to calculate is the thrust force due to the pressure field. And thrust force is rho g a y bar. For density we have 1020. Gravity is 9.81. The area of a circle is pi times radius squared. Well, we have a diameter of 4.5. Therefore, we have a radius of 2.25, half of the diameter. So we have pi times 2.25 squared, and y bar we just calculated 8.75, giving us a thrust force equal to 1392.5. And that's kilonewtons. I've already carried out the conversion there. The next thing we need to determine is where that thrust force acts. As we said previously, that thrust force is horizontal and it acts at the centre of pressure. So we need to determine the distance from the free surface, SS, to the centre of pressure. Now that distance is given the variable h bar, and the way that we calculate h bar is by doing ISS over AY bar. We already know A and Y bar, but we need to calculate ISS. The formula for ISS is ISS equals IgG plus AY bar squared. Now in the previous video, we explained that IgG was the second moment of area about the centroid. The centroid is given the axis legend GG. And second moment of area is something we've calculated in previous tutorials. The second moment of area, IgG, about the centroid for a circle is pi d to the fourth over 64. Therefore, ISS is IgG pi d to the fourth over 64 plus AY bar squared. Well, the area of the circle is pi r squared, and we have our value of y bar of 8.75. If we input some values then, we have pi times 4.5 to the fourth over 64 plus pi times 2.25 squared times 8.75 squared, giving us an ISS value equal to 1237.80, and the units there are metres to the fourth. But recall that it isn't really ISS we want to calculate. What we want to calculate is h bar, and h bar is ISS over AY bar. Well, we have our value for ISS, 1237.80. Our area is pi times 2.25 squared, and y bar is 8.75. Now running that all through the calculator gives us an h bar value equal to 8.895 meters. So over on the left hand side we have h bar equals 8.895 meters. And as we mentioned previously, the value of h bar will always be slightly greater than the value of y bar, so we've confirmed that through calculation. The final step then is to calculate turning moments. Now for the circular surface, we're going to calculate the turning moment about the centre, or the centroid. The reason being, it probably wouldn't be practical to fix a circular surface on the bottom edge. We only have a very small point of contact, so instead we're going to fix this at the centroid. Therefore, our turning moment, as before, is force times distance. But the distance that we need to use is the distance between the centre line and the point of application of the thrust force. So if we label this on our diagram, what we're referring to is this small distance here. Well, this small distance, using the free surface as our reference, is just h bar minus y bar. Therefore, we have 8.895 minus 8.75, giving us a value of 0.145. So finally, we can calculate the turning moment about the centroid. It's our thrust force, and I'm going to use the value in kilonewtons, noting that my final answer will be in kilonewton meters, times d, 0.145, giving me an overturning moment equal to 201.9 kilonewton meters. So in summary, in the previous video we looked at how to determine thrust force and overturning moments on square submerged surfaces, and in this video we've looked at how to calculate thrust force and turning moments for a submerged circular surface.